In this video, we'll be more attentive to the pressure that's acting on the hydraulic motor. Very specifically, we have a pressure measurement on the A side, that's shown in yellow, and one on the B side that's shown in blue. It's the difference between these two that we call delta P. And if yellow is higher than B, positive delta P, that will lead to a positive torque, and of course vice versa, we'll get a negative torque. All right. I want to talk just briefly about the spool position. Spool position is kind of this cylinder, kind of long, skinny rod with cutouts. And it's again, brilliant, very clever idea. And it's kind of the movement of the spool that really determines how the ports on the left-hand side of the valve connect to the ports on the right-hand side. All right. And so if spool position 0, everything's blocked. If spool position's positive, flow goes from P to A and T to B, and if it's negative, it's the opposite, right? And then the final kind of comment on spool position is that there's a proportionality to how much flow is exposed that's equal to kind of the magnitude of the spool position. All right. Okay. So anyways, that's our control. All right, and moving that spool position properly will lead to this really ideal motion that we get. And so the nature of the controller, though, it's a two feedback. Well, it's got two feedback loops. They use terms like inner loop and outer loop, and certainly the inner loop is going to be on the torque control, and the outer loop is going to be on the position control. All right. And so let's look at our controller. Okay, there's our inner loop right there. And the job of the inner loop is to take our torque feedback, compare it to an ideal estimate of what we want the torque to be to get the motion that we think we can get, and then to take that difference and allow a PID controller with these values, which have been tuned very carefully, to operate on identifying the position we want the spool at. Okay. Now, all this math in front of that, well, that's really to get that ideal torque that we want to deliver on that shaft. And it's got a feed-forward component, which is going to be equal to the acceleration we want times the shaft inertia. And that's going to have, again, this little bit of feedback on position. So if we overshoot a little bit, the job of the PID is to bring it back. All right. And with that, I think we do really quite well. Thanks for watching.